Okay, the subject what we are going to study is known as electric network analysis. Okay, so let us get introduced into the various the standard terms that we will be using in the course repeatedly, and then the syllabus, what to be studied and what not to be studied, and what is the weightage we are getting and what kind of questions we are getting from this course, and apart from that, how to prepare this subject and what is the importance of these particular topics. So let's have a discussion on that. See, particularly if you take any of the standard textbooks which is available in markets, I will tell you the book name. So you take any of the books, you will find the title names, the authors are given like Fundamental of Electric Circuits, Electric Circuit Fundamentals, Network Analysis and Synthesis, Electric Network Analysis. Like this, the terms those are being used. So frequently if you see these books in the cover page itself, so these are the frequently used words such as network, circuit, analysis and synthesis. First listen, you don't get any question from this part, but still you should have some idea. Now even if these two words networks and circuit we are using interchangeably, many times we don't really care actually what is this network or this circuit. Whenever some RLC network is RLC combination is given, we say sometime it is network, sometime we say it is circuit, without making some difference between them. But strictly saying there exists a minute difference between this network as well as circuits. So let me tell you what is the similarity and what is the difference between these two. Okay, and again, so if I feel some points to be written on your notebook, I'll write in the board, okay? And when I'm explaining you, please do not get deviated. Listen here what I'm saying. So first thing is, the simple way to define the network is any arbitrary interconnection of electric element constitute a network that may or may not have a further closed path. Any arbitrary interconnection of electric element constitute a network that may or may not have closed path. So that is said to be networks. However, if the network having at least one closed path, it is said to be both network as well as circuit. Now this statement may not be, you may not have understood what I said actually. So now what is the meaning of electric elements? Meaning of electric element means those elements which responds to voltage and currents. There are so many elements of course, but the popularly used elements as per our course is concerned, such as resistor, inductor, capacitors, batteries, current source, etc. These are the electric elements. So what I am doing is, so if I take something like this and if I connect a resistor something like this, so I will say that this is a network but not circuit, However, coming to this, I mean why I am saying like this? Because this is arbitrary interconnection that may or may not have closed path. So in this case it is said to be only networks but not circuit. However, if I do something like this, let's say I am closing the path something like this, so I will say that it is both network and circuit. So in other words, a closed path is compulsory condition to pronounce this as circuit, okay? But whether closed path is there or closed path is not there, it is always can be said as networks. But circuit word is we have to use it if at least there exists one closed path in the connections or in the interconnections. So from this analysis, what can I say then? I can say that all circuits are networks, but all networks need not be circuit. Is it not? All circuits are networks, but all networks need not be circuit always. So that is what the fundamental difference between the network and the circuits. But due to the habit from the 12th class onwards, we literally don't care actually when to say it is network, when to say it is circuit. So we use these two words interchangeably. In fact, I'll also be using sometime the word interchangeably, network and circuit, without much sticking into these particular configurations. You should not try to point out the mistake like why you are saying the network, why you are saying circuits. So if you say like this, I will say that I cannot change my habit. So you should mean, I hope you understood what I mean to say, right? So this is what the basic difference between network and circuit. So this diagram itself are self-explanatory, right? Okay. Now what about the analysis and the synthesis? What is the similarity and what is the difference between the analysis and synthesis? See, any problem in the networks, or if you take the analog electronic subjects also, there are two ways or two varieties of problems. One is analysis based problem, one is synthesis based problem. Not only that, I can also say in the digital recently we studied, where we discussed the counter circuits. In the counter circuits, what I have given is there are two kind of problems are there. What are those problems? Those problems are, one is design the counters, one is analyze the counters. So design the counter means counting sequence used to be given to you. You are supposed to draw the circuits. So that is what we mean by the synthesis. That is, the counting sequence is given, the requirement has been given to you, and you are asked to design the system or the digital circuit. That is said to be synthesis based problem. However, if the digital circuit itself is given to you and you are asked to find the functionality of that, let's say counter circuit is given, you are asked to find what is the counting sequence of this. So those model problems are known as analysis problem. Similar way in the networks also, whenever a network is given like this or a circuit is given like this, if you are interested to find the voltage and current or power, something like that in the networks, so that is another analysis based problem. However, sometime what they will give is, so they will say that input is this much, output is this much. So design a network such that which will satisfy this input and this output. One of the popular example I'd like to tell you, like suppose I am saying you that, so take a inputs of plus minus 1 millivolts sinusoidal voltage. Now design a system, putting this in the box, so that the output of this one is something like plus minus 5 millivolts. So this is plus 5 millivolts, this is minus 5 millivolts. Now when I say this is what my input and this is what my outputs. Obviously that it is clearly visible that I am asking you to design an amplifier itself, because amplifier is one which increases the height or the amplitude level of this without changing the shape, right? So we are expecting an amplifier of gain equal to 5 here. So if I want to design this, so that kind of problem what I will solve, that is known as the synthesis based problem. Input is given, output is given, you are asked to design the system. But here let's say I am giving you some value 2 volts, 1 ohm, 2 ohms like this, and I am asking you find the voltage or current something like this. So this is known as the analysis based problem. Network is given, you are asked to find the response, that is analysis. Input output is given, you are asked to design the system itself, that is said to be the synthesis based problems. Okay. Now one more problem or advantage, both you can say this in this case, that you see that in this case particularly when I say it is a synthesis based problems, that the input is plus minus 1 millivolt, output is plus minus 5 millivolts. Now what kind of amplifier it is? I know that this is amplifiers, but in analog electronics you learn there are so many kind of amplifiers. Like amplifiers can be designed using BJT, it can be designed using MOSFETs, it can be designed using the op-amps, or there are a lot of new devices are coming day by days. So there are so many solutions of this particular problem exist. Let's say that you are designing by op-amps. So what kind of resistor you need along with op-amp? What is the gain of op-amp you need? Or do you need any capacitor kind of things? So those all things has to be decided by you. See, for example, when I take a op-amp based case, let's say like this, if I take a, the non-inverting case, right? So I can select this is Vi, let's say, this is V0, right? This is RF and this is R1. And I hope all of you know that this V0 is given by Vi into 1 plus RF by R1. That's what the gain formula of this non-inverting amplifiers, is it not? So what I want to say, that you see that if I am designing this particular amplifier by using these op-amps, so the circuit will look like this. Now I can select this value of RF and R1, I can choose this value in such a way that which will satisfy my requirement, the gain has to be 5. That means if this is 1, so I am expecting that this ratio should be 4. Now what can be the value of this so that ratio should be 4? There are infinite possibility. You can take this is 4, 1, you can take 8, 2, 8, right, 8, 2 you can take, or you can take 16, something like this. There are so many possibilities exist for this. So that's what I am saying. The solution of this particular problem is not unique. In fact, I am showing this with respect to the op-amp itself. The same gain 5 if you want to implement using BJTs. So along with this, you need some capacitors, the DC blocking capacitor, bypass capacitor, these, that, lot of other things are there. So that circuit will look something else. If I have designed using the JFET or MOSFET, that will again look something else. So the point to tell you is, the solution of a synthesis problem may not be unique in nature always, right? It may be, may not be. Not only that, there is a chance that the solution may not exist also. So first thing is that you should check like whether the solution of this problem is particularly possible or not. If possible, how many solutions are there? If there are many solutions are there, as a design engineer, it is your responsibilities to select which design is optimum in terms of cost, complexity, power, etc. So that's the way that how the things are being done. But coming to the analysis based problem, the solution is always unique in nature. Always unique in nature. Like whether you solve a problem or I solve a problem. So unless until we are not doing any kind of calculation and conceptual mistake, no doubt that answer has to be same. It is always unique. But in this case, if I give this requirement in a class, I may get 5 to 7 different answers. All might be correct. But that is not the case. That is always unique. This may or may not be unique. So this is what the difference between the analysis and the synthesis. Okay. As far as GATE syllabus is concerned, we have to learn only analysis. We have to learn only analysis. We are not going to learn the synthesis part. In the last year IES exam syllabus, old syllabus, you know that IES exam syllabus has been changed. The synthesis part was also included. The content you might have learned in your BTech days also, like Foster 1 form, Foster 2 form, Core 1, Core 2, positive real function, or some heuristic criteria, like this, lot of things are there. So those all things comes from the synthesis. If you remember, so what they used to give is, they used to give you some network function kind of things, and they will be asking you to design the networks. So when you do some synthetic division kind of thing, finally you draw a big networks and you write the inductor value is this, capacitor value is this. So in that case, what you are doing, from the network functions, you are designing the networks and you are finding what can be the value of this L, this C, these things. So those are the design part or the synthesis part. So that's what we are not going to see. That is not in the GATE syllabus. Or in fact, in the new IES syllabus also, this part has been removed, right? So this is not there. For IES also, if you are preparing, this part you need not to learn. Okay. Now, why the name I have given it is, the course name is Electric Network Analysis is, the kind of energy sources what we are going to talk in this course, they are always electric in nature. They are not mechanical in nature, something like temperature, pressure kind of things. Always the kind of energy source what I will be using, they will be always voltage and currents, which are in general electric. So I am using the word electric. And compared to networks and circuits, network is the more flexible word compared to circuit. It fit more. So I am using networks. And in the GATE syllabus, we don't have synthesis, we have only analysis. So I am using the word analysis. Combiningly, I am saying it is electric network analysis. Okay. So if you go to the syllabus, in the triple it is written that electric circuits, and in the EC it is written that networks, like that it is written. So if you see the content of EC and electrical, they are 99% it is same, right? There is only 1% variation, but that is almost same. Okay, so that's what some introduction to this network analysis. Okay, so let me write down this statement. Take down. Any arbitrary interconnection of electric elements constitute network that may or may not have closed path. However, if the interconnection comprises of at least one closed path, it is said to be both network and circuits. Any arbitrary interconnection of electric element constitute networks that may or may not have closed path. However, if the interconnection comprises of at least one closed path, it is said to be both network and circuits. So you might make a slash like this: networks and circuit. Combined definition I have given. So one more statement what I said is, all circuits are network, but all networks need not be circuit. Shortly we write it is CKT, and we write this as N/W, networks. So this is the difference, and you can draw these two diagrams. This is network but not circuit. This is both network as well as circuits. Okay. Next point is, from a given network, finding the response such as voltage, current, power, etc. is known as analysis based problem. From a given network, finding the response such as voltage, current, power is known as analysis based problem. And its solution is always unique. So this is one more popular question always. If you go to interviews also, sometime they may ask what is the major difference between the analysis and synthesis. The first thing is that you can say the definition, but the difference is solution is always unique in nature in analysis. But here, designing the networks from prescribed input-output relationship, is known as synthesis. It may have multiple solutions. This is what the fundamental difference between the network circuits and analysis and the synthesis. Okay. Well, so I hope like from the day one when I'm keep on teaching you this, whether it is digital or something like this, one common thing actually like, okay, let me tell you what is that. Something is coming to my mind. Let me share that thing with you. See, okay, it's something regarding the English. That is, what should I pronounce to this particular word? C-I-R-C-U-I-T. What should I pronounce to this particular word? See, in the South Indian state, it is pronounced as circuit. In South Indian states, we are pronouncing this as circuit. But if you go to north, right, it is pronounced as circuit. If you go to West Bengal, they pronounce circuit. I have seen in physical class when I go. So this words has been, used in different flavor in state to state wise. So I'm using the circuit here, right? So it should not feel odd. And in fact, if you see the dictionary, So there are both are correct actually. Circuit is also correct. Circuit is also correct. So both are absolutely fine. Anyway, this is not a grammar class. Even if there is a mistake, who cares? This is not an English class, right? Okay. Okay. Having said this, now what about the importance of this particular topic? So see, initial 45 minutes will be the introduction only before I enter into the course actually. See, whether you are from ECE, electrical or IN, the most fundamental subjects that is needed to understand the remaining all these things is, one is the networks and one is the signal system. These are the two subjects whose fundamentals are very crucial, which are needed in almost all of the subjects. If you are not good in the networks, you cannot solve most of the problems in the analog electronics. Particularly if you see the questions of analog electronics, so usually they are asking the clipper, clampers, finding the gain of amplifiers, op-amp based things. Everywhere you need to have the very good knowledge in the networks. Of course, you don't need very extraordinary networks, but at least if fundamentals are not clear, so again it will be a huge problem, particularly in the analog topic. Not only that, in the control systems also, there is a topic called compensators. So there again you will find the transfer function of the compensators in the controllers also. So these concepts are pretty much useful. Now coming to signals also, some questions they are framing by linking the networks concepts. That's the thing. And particularly in digital, from the last 2 years, so you see that instrumentation paper, some nice question they have framed, and electrical one monoswat multimeter question they have framed, where again the network concept has been used. And I have not solved that things because the necessary background, what is needed for that, I am not sure whether you know or not. So once I will complete those things, those questions I will take up in the network class. So that is very crucial one, networks and signals. Remember, similarly, like the way it is happening in the signal system also, that is also very crucial one. Why it is crucial one means, communication particularly if you take the topic, right? So without signal system, communication is like hell. Not only that, so there are so many things, even in the network also, we need those things. Why is that is, sometimes they will be giving you some, some voltage waveform. You are asked to draw the current waveform like that. So if you have good background on the, from the signal point of view, so those questions just by visualization itself you can answer. Otherwise, you have to again write the equations, you have to struggle. So please make sure that these two topics should be perfect. So in fact, if you are from electrical background, in the power electronics case also, that is also very much crucial, signal system. You learn the harmonic concept, and in the networks, you might be knowing, right, in power electronics, each and every problem RLC network with diode, thyristor, use that. So that is a very important topic from the, say like a background subject I can say. That's the reason you take all the syllabus, ECE, electrical, IN, GATE syllabus you take. What you will find is, you will find that after the engineering maths, the first topic what has given is network. You check it. After the engineering math, the first topic is, it is given as the networks itself, right? Then it is given as signals. And that's the sequence actually you should follow. First math, then these things. And of course, digital is a independent topic, so any moment of time you can do it, if that's fine. But signals and networks, these are very fundamental topics, and you should be really good to enjoy the remaining topics. Otherwise, so if you understand the subjects, these networks and signal, you'll enjoy the remaining course like anything. Otherwise, you'll struggle like also anything. That's also there. Of course, you will feel it. You wait if you are not regular in the class. Okay, so that's fine. And almost all topics like machine, power systems also, everywhere you need the concepts of something like this. Okay, having said this, now what about the weightage we are getting in the GATE exams? See, actually, like earlier days, particularly prior to 2015, it was, like in a confident way, it was possible to say like we are getting this much of mark. But nowadays, if you see the 2016 papers, in some of the sets, the randomness is increasing like anything. Like in electrical, one set digital was asked only on 3 marks, another set was 7 marks. So from which topic, how many marks they will ask, that is not sure. But yes, if you see the previous year statistics, so 8 marks minimum marks you will get. definitely in all ECE, electrical and IN. 8 mark is minimum one. And in 2012, they went up to 16 marks. Right. And this is too extreme, of course. In that year also, digital, they have reduced the weightage. Of course, if one subject weightage is high, some other subject they will balance it, right? So digital they have cut it and network they have increased. So that is the highest in the entire history. In 100 mark paper, only network is 16 marks. That was highest. But 8 mark is minimum and 8 to 10 is the average range you can take. That's the questions we are getting from this. And these topics like digital, these networks, then signals, controls. So these are some topics, these are purely scoring topics. You should not miss a single questions. Networks, truly I am speaking you, today I am starting the class. When I learned the class that day, when I learned the course, then also I will tell you that in the entire course, I am not going to teach anything to you except the Kirchhoff's law and Ohm's law. Of course, in between phasor will come, transient will come, Laplace will come, these, that, lot of things will come. But ultimate thing is the main idea is only the KVL and the KCL and the Ohm's law. Kirchhoff's law, Ohm's law. Based on these two law only, we are going to complete this entire course. So, if you know the approach actually, so there is only one topic known as electric network, that is the fundamental topic, the first chapter. I'll tell you the sequence on which I am going to follow the course. So, that is the first topic is the only thing that what you should learn. And you should not miss any questions. So, all the questions are the similar model, similar model. At least in some other subject like, let's say, if I take the example of communications or EDC, nowadays some new varieties of questions we are getting in the exams. But when it comes to networks, controls and all, these are saturated subject. You don't, very rarely you are getting some new model questions. At least in digital also something they are asking nowadays. But networks and controls, these are two subjects where you don't find any new model questions. All are the same previous year model, different ways they are asking. You can see it. Like I will be solving the paper up to 2015, I guess, right? 16 collection I will not take. And I will ask you to use a test yourself. Like after being solving 2015 up to 2015, which question is new into 2016 that you should see and you should gain the confidence. Okay? And I'll let you know like after completion of one topic, so which questions you should attempt for 2016. I'll write in the board as you will progress. But coming to engineering service examinations, so in the old papers, so you might be knowing that. So there are 800 technical marks in the old IES paper. So it was 1200 marks, total full marks, out of which 200 mark is the non-technicals and 200 mark used to be the interviews. 200 marks used to be the interviews. So written technical was 800 marks. Out of this 800 marks, approximately 90 to 100 marks questions you get only from networks. IES, any year exam question you take, almost 100 marks you will be getting from the networks only. It's a highly weighted topic in the IES, but GATE randomness is increasing, you cannot say. IES it is not that random as like GATE. Okay, so let's see the syllabus and the sequence on which we are going to learn the topic. So take down. So there are three parts I am dividing this. One I am writing this as DC network analysis. And then I am writing this as DC network analysis. And then I am writing this as some miscellaneous topic. So the chapter number 1, what we will be learning on this is, that is known as the fundamentals, which is the longest topic in the entire syllabus, that is the fundamentals. Chapter number 2, this is network theorems. Network theorems. And chapter number 3. Okay, so again this chapter number 1 and chapter number 2, I'd like to call them as resistive networks. Okay, I'd like to call them as resistive network. In the sense, okay, so we are going to spend almost around 23-24 hours of time on these two topics only. So in those 24 hours of time, we are not going to talk anything regarding the inductor capacitors. All the network will comprise of only batteries, voltage source, current source, and resistor. That's what it is, resistive networks. So the third topic is, here I will be introducing the inductor and capacitors. I have taken one particular topic for this, which is the background topic needed for the transient analysis particularly. So here some of the interesting properties of the inductor capacitors we'll learn, which as you might have heard, like inductor doesn't allow sudden change of currents, capacitor doesn't allow sudden change of voltage, inductor behaves as short circuit for DC, capacitor behaves as open circuit for DC. This statement you might have heard. So all those related property-based things I'll be discussing on this topic. And the fourth topic is known as first and second order network analysis. First and second order network analysis. And in fact, this is what the transient topic we say always. But that name is not correct actually. You should not say it transients. I'll tell the reason why is that, why you should not say it transients. So these are the four topics that comes on this. Coming to this, the first chapter, so what we will be learning here is chapter number 5, sinusoidal steady state analysis. Sinusoidal steady state analysis. So where we'll be learning the concept of phasors, right? So phasors and how to find the voltages and currents when the supply is AC. Like as I said, like the name itself indicates, DC means the source is DC here. AC means the source is AC. Popularly it is a sinusoidal case. So if the input is sinusoidal, how to find the voltage currents in the networks when RLC all elements are there. So that all things will be taking on this sinusoidal steady state analysis. And one of the very important topic nowadays, you see the 50% of the questions from the GATE, those are coming only from this topic, sinusoidal steady state analysis. In fact, all this concept, whatever things I will be discussing on these two, once again the same thing will be repeated here. You need to understand these two only. If you need to understand fundamentals and network theorems, then there is a new thing only you have to learn, that is known as phasor. If you learn what is the phasor, so there is nothing difference between the remaining content of this and these two, right? So these two are very crucial, the background topics. So after this, there is a topic called resonance. This is also one of the important topic nowadays. A lot of questions they are asking, right? So these two are coming on this. And coming to this miscellaneous topic, so we have two-port networks and some basic idea regarding the filters. Right? And you take down, this is some other topics. So what we might discuss in the other topic is like locus diagram is one thing, which is not specifically mentioned in the syllabus, but if you refer the old paper in both EC and electrical, so that has been given. Okay, let me write down particularly otherwise. Locus diagram. A very small topic, not more than filters also, not more than half an hour. This is also not more than half an hour. There is one more topic called network functions. So this was also given in the EC syllabus, and questions they are asking. This is also a small topic. So this entire three topics, it's not more than 1.5 hour to 2 hour at max. Very small topics. And the magnetic coupled circuit, that is not given in the syllabus. But let me see, like if time permits, I'll touch that also. Right? Coupled circuits. It is not in syllabus. If time permits, I'll touch, otherwise not. Coupled circuits. Okay, and strictly saying, and if you refer the electrical syllabus particularly, the three-phase circuit, three-phase AC circuit is also given in the network syllabus, but in my opinion, or you also know that, so the things you should study that in the power system topics, because when it comes to networks, we restrict ourselves in a single phase. The application of that, all those things you learn in the power system topics. We'll see, like, and all the questions what you get from that, those are again related to power systems only. I have seen those things. From network point of view, if I discuss, that is not more than a 1 hour topic. So simply, there are two kind of connections, star and delta. So what is the line voltage current relationship in star, delta? Those topics I need to discuss. There are two topics actually, power system and in measurements, where you will be learning the measurement of power. There also you will be learning the three-phase network concepts. But it is given in the network concepts. So if time permits, I will touch that also. Otherwise, you will be learning in that in the power system course or measurement course, three-phase network analysis. Okay. And what else? That's it, right? Yeah. One more thing. Network graph is also given in the electrical syllabus. It is not given in the EC syllabus. Earlier old syllabus, in the EC it was there. But from EC they are removed. In the revised syllabus, in electrical they have added. Earlier in the electrical it was not there. In fact, there is no question on this. This is a theoretical topic. Even if you don't know any networks, you just take that book and one day you see it, you will be learning those theoretical topics. So some idea regarding this also I'll give. So this is what the sequence and the flow on which we are going to learn these things. Okay. So if I say that there are 10 marks are coming from this, this entire topics, so you can expect 4 marks from this, you can expect 5 marks from this, and you can expect 1 mark from this, all topics. If you do the analysis of the previous 10-15 year paper, so this is what the rough estimation you will get. But nowadays, if you see the 2014, 15 and 16, this topic and this topic, so both are highly, they are touching most of the questions from this. Of course, the questions are not tough, but weightage is good from these two topics. Sinusoidal steady analysis as well as resonance. And this topic, some very nice analysis based questions they are also asking. We'll solve those things in resonance. Okay. So this is the sequence and these are the contents on which we are going to complete the course. Okay. To start with, let's take the topic fundamentals. And again I am saying, in the entire topic or in the entire course, the only thing that what you are going to use is the Kirchhoff's law and Ohm's law. And remaining all things, you might have heard the current division, voltage division, source transformation, nodal, mesh, star, delta. All these are again the application of Ohm's law and Kirchhoff's law only. And please try to understand this fundamental topic very easily. In fact, the good thing about the networks is that this topic is not a new topic. Somehow the voltage current concepts are being introduced from class 7 and 8 onwards nowadays, where the series parallel connection kind of things at least you have learned from the class 7 is onwards. So that is a very smooth transitions we will have. And in fact, most of the concepts are known to you, many of you. But even if you might be knowing all these things, but don't take anything lightly. So there must be, like if I solve some problems, the problem what I have taken, most of the problems are from the gate. And almost in all the problems, I'll be giving you some kind of observation-based things. And that I'll be using in the future classes repeatedly. So please don't take the things lightly, right? So please try to listen everything completely. Okay, so once this topic is clear, then there is this, whether you take theorems or you take AC, you take resonance, you take two ports, everything should be very smooth. This is the only topic that the major thing we have to learn. Usually, like when I was a student, and even when I go to the classes and when I ask which topic is considered to be toughest one, most of the guys, they say the transient and AC. So I feel, like, in fact, I was also feeling like that in my student careers. So transient and AC were the tough one. But the only reason that why those two things are being tough is because this topic is not clear. Because there are some situations where, your mind will block actually. You cannot proceed actually. The reason being this topic is not clear. In fact, I know that after the completion of this also, you may not be learning a very good amount of things from these topics. But once we'll go to the AC and transients, you'll really feel that what is the importance of this topic on those two topics when you solve the problems very easily. So, okay, so please take care about this. Okay, as I am highlighting this much, let me show you the sequence on which, or what are the subtopics of this particular chapter fundamentals. So first thing is that, so I am giving a map of this like a book. So first thing is that condition for flow of current. Just take down the sequence. Second thing is basic electric quantities. Basic electric quantities. Third thing is mechanism of electrical energy flow in conductor. Mechanism of electrical energy flow in conductor. Fourth thing is the power convention and intelligence theorem. Intelligence theorem. Fifth thing is resistance. Sixth thing is electrical energy sources. Electrical energy sources. Seventh thing is node, branch, mesh, loop. Eighth thing is Kirchhoff's law. Ninth is circuit solution by inspection method. Circuit solution by inspection method. Next, series interconnection and voltage division principle. Voltage division principle. Parallel interconnection and current division principle. Next, resistance reduction technique. source transformation technique. Mesh analysis. And finally, nodal analysis. So these are the content we are going to cover on these fundamental topics and in this following sequence. So in each and every topics, I will be writing the sequence and what are the subtopics like this. So we will write like this and write the note carefully. So even if you prepare for the next year also some more time again in future due to some other exam or something else, these notes will be always be useful to you. Okay. And you are getting a minimum 2 to 3 marks questions you are getting from this topic also. Sometime. As I said, from that total topic you are getting 4 marks approximately. So sometime transient only 1 mark question they are asking. So but fundamental they are touching some questions, particularly resistance reduction techniques. They are all nowadays, that is one popular model question in almost every stream and every sets. And you'll see like in the fundamental topics actually the concepts what we are going to talk about, 90% of the things are from the 12th class only. That is nothing engineering concepts. Almost everything is from that only. But we'll see everything in detailed manners. If there are some hidden points, we need to have a note on those things. Okay. So what should be the approach to study this particular course? My dialogue is same in every course, irrespective what I teach. That first listen the lectures, then solve the previous year problems. In fact, in the class itself, what the problems I'll be taking. So those problems, 90% of the problems are from the previous year GATE only. Most of the problems are from previous year GATE, and very few I have taken from some standard textbooks. But most of the problems are from the previous year GATE question banks. You should have also the same approach. Listen the lectures and solve the previous year problems to gain the confidence. Okay, so some guys ask, will the GATE problems will be only sufficient? Then I used to ask, can you solve all questions? Right, it's not that easy. And in terms of quantity also it is not small. And if you are a EC student, don't think that you are going to solve only the EC problems. Try to solve the electrical as well as instrumentation problem. If you have still more time, if you have solved all the problems of EC, electrical, IN, solve the IS problem then. My point is, why I am saying to solve this kind of problems is, as I said, particularly networks and controls, you are not getting any new model questions. Why you are not getting a new model question is, the international standard book which are being followed throughout the world, there is not a single page, single concept left out in the GATE which has not yet been asked. You take any of the standard textbooks and you see the previous year GATE question bank, everything they have touched. So in that book, nothing is there. The only new kind of things what you are getting is they are creating some questions by linking to the signal system concepts. So leave those things. But as far as network is concerned strictly, you don't get any questions beyond that because everything they have touched. If the book itself is over, then what will do then, right? So that's what the thing is. And moreover, what is the reference book that you should follow for this particular course? Okay. So reference book, okay, why I am giving this? Because always there is a curiosity among some students. They want to know what is the reference book. But, what is the main role of this particular coaching is just to tell you what to study and what not to study. If you start reading the book from page 1 onwards, there are 900 pages and 1000 pages in one particular book. So if you start reading like that, you may not be able to complete 1 or 2 subjects in the entire 1 year. So books should not be used in that way. Books should be used. If you are getting some doubts, if doubt is not getting clear, there is no one else there to help you, then you should refer that. It's not like page 1, page 2, solving each and every problem. That is a foolish idea. Because you are not going to prepare the GATE exam for 3-4 years. You have simply 6-7 months of time. You have to plan all the subjects. So please restrict yourself. Okay. The number one book, which is this is known as, okay, not number one, but it's a very good book. Engineering Circuit Analysis. Engineering Circuit Analysis. The author name is Haight and Kemerly. Haight, Kemerly, and Durbin. There are 3 fellows. This comes in TMH publications. Next one is the fundamental of electric circuits. The fundamental of electric circuits. And the author name is Alexander and Sadiku. Sadiku book is well known for EMT, and also he has written the books in the networks also. That's also very awesome. The basic difference between this book and this book is here the conceptual analysis is a bit more. Problems are less. But whatever problem he has given, most of the problems are, you have to learn something, observation based problems, most of the numerical problems. But coming to this, you will find like this a local author kind of things. I mean, not local author means don't think that is a low level kind of things. No. Whatever you will explain, he will give sufficient example for that. So, lot of examples you will find. And theoretical discussion also pretty good. If you ask me to purchase which one, I will say that you go for this. Back exercise also lot of problems you will find. And its online solutions are also available in the website. If you do a Google search, you will find the solution of this also, the back exercise problems. And if you refer the back side of these books, right, the reference, there is one more name you will find, which is Sergio Franco. This is the best book in the networks as per my knowledge. You refer this book or this book, in the reference you will find this. 1992 this book has been written, and Sergio Franco, he is a professor in San Francisco State University, has written 3 books. One is Networks, written in 1992. One is the op-amp books. Today throughout the world, that is the op-amp book also number 1. And in 2015 analog electronics books also this person has written. But network is really awesome. But again the problem is you don't find this in Indian market. You go through Amazon and some online sites, 16,000 is the price of this book. Okay, so, and the book name is Electric Circuit Fundamentals. Electric Circuit Fundamentals. This is what the book name. Author name is Sergio Franco. And the publisher name is some Saunders College, some US publications. This Indian edition is not available. So, these are the things. Let's take a break and we'll start with the subject.